Hello, I am Dorota, and you are a small cozy group that I'm going to tell you about ECS. ECS, but not the Amazon thing. If anyone came here for the Amazon thing, please leave. That was your moment. ECS stands for Entity Component System and is something that's used for games. And you're going to have to focus really hard now because I don't have enough time to prepare the presentation correctly, okay? Actually, maybe just let's relax and look at some birds. What is this bird? Come on, come on. It's a penguin, but it's not just a penguin, it's a chinstrap penguin. Can you believe that? It's crazy. And what is this bird? Come on, speak up, speak up. It's some kind of... I thought you would be more confident because I have no idea what this bird is. It was on my porch. And what bird is this? This is the Bevy bird. I fooled you. We're not going to relax. And what is Bevy? Bevy is this game engine. It's a game engine that is based on ECS, on the Entity Component System that I'm going to show you. And I'm really going to show you because I have some demos. And Bevy is really, what is it? It's really fast. Look at that, 10,000, 20,000, 30,000 birds are scrolling around the screen at 15 FPS on this weak laptop. So it's quite fast, and look at that. Oh wait, no, that's the same demo. And there you have 1,000 foxes spinning in circles also at a decent speed on this computer. So ECS is fast, but that's not the only thing that ECS is. ECS is also kind of cool, you know? I tried so many different game engines through my life. I tried Godot, I tried Luve, and I tried probably like 5 or 6 different ones that I don't remember right now. And none of them really clicked in my head until I used Bevy, and then I don't have a demo because it stopped working, it stopped compiling, but I managed to complete something in a game engine. It's a lame simulation, but it's different. It's some paradigm that I managed to actually use. For me, that's amazing. So let's take a look why. This is like an example code from an imagined object-oriented programming language. It has like a thing that's a looker, presumably some kind of a mob, an animal, and it looks at shiny things. So you have like an on-click procedure where you click the looker, it takes a look at the next shiny thing. But what is this here? Why does the looker contain all the shiny things? Shiny things are around, all around the world, and that doesn't make sense because if there's many lookers, you have to copy all the shiny things, and that doesn't make sense. Let's do it this way. And then it's not 7. Looks better, right? But then how do I load the things into the on-click procedure? And I would get stuck on that kind of things when I was working with object-oriented stuff. Meanwhile, with ECS, I don't have to think where things come from because I have a system that magically gives me all the lookers and all the shiny things that are in the world, and I can just iterate over them. As you can see, there is a simple loop and just does the right thing. I don't have to worry. And the problem of being stuck thinking about where things come from is completely solved. And yeah, that is kind of magic to me. But what kind of magic is this? Data, come on, data. Data-driven magic, you win this time. And yeah, before I get into details, let's go back to the year of the Lord 1998 and the game Thief the Dark Project, where ECS, as according to my 10 minutes of research on Wikipedia, was the first game that featured an ECS. Who played that game? Yay! Who played that game at release? I was hoping for it. Is this good? Is it actually good? I wanted to play it, but didn't have the chance. I could have a go. Well, and look at other games. Well, it's mostly games that are using ECS. There's a bunch of them, and I couldn't find like a single example of something that's not an ECS and I didn't try it, that's not a game that I didn't write and doesn't use ECS. And why is that? Because ECS are like extremely good for games. They are fast. Why are they fast? Because they use a pattern that I'll get to. Normally, when you use a typical design, you have this structure. Structure can be an object, and when you have an object and you have like contents of the object, fields in the object, they are placed in memory one after another. There's like a position, rotation, smell. They are one after another in memory. But if you have many objects, the objects are also one after another in memory. And this is not amazing, because if you think about accessing just one piece of this puzzle, the rotation, one rotation, you have to skip a lot of memory. And this is inefficient because memory is separated into cache lines. And each cache line has to be fetched separately. And if you compare it to the pattern that ECS uses, it looks a bit different. It's called structure of arrays as opposed to this array of structures. You separate those position, rotation, smell into their own arrays. And instead of having like a line of objects, you have a line of single property that you care about. So if you want to iterate over our rotation, you only have to fetch one cache line every couple of items that you iterate over. And this speeds up the computation tremendously, because our computers these days are really slow at accessing memory. So this is a cache-friendly layout, and this makes it especially suitable for games. Because what do you have in games? You have a lot of systems that are like spatially oriented, or a lot of components, a lot of code that just wants to iterate over things. So we have an example here of the system that moves things that can move, and it would just iterate over all of them. I don't know, 1,000 pieces of grass, or your clouds, or all monsters in the game. Whatever that is, iteration is great. But what does entity component system really mean? In comparison to object orientation, we could draw like an analogy between an entity and an object. Well, as a component would correspond to a field. And what would a system be? Well, that would be something actually unique. But let's take a look at an entity. An entity is composed of components, just like an object would be composed of fields. But if you have different entities, they can have different components, organizations. Note that I am not saying a type, I am not saying a class. This is going to be important because when you look at how those fields are laid out, they are still laid out in this structure of arrays pattern. They are getting mashed together regardless of what ordering or like what set of components an entity has. So you get all the components of the same time, always on the same in the same like memory area. And this is important because it gives you some superpowers. You don't have to stick to a certain layout of your entities, but you can add components dynamically. You can insert components into your existing entities, and you can also remove them. This is like changing the type of an object at runtime. It's kind of crazy, actually. But let's get to systems, because they are also the unique thing and very important, very, very cool, actually. It's the closest thing to import anti-gravity that I've seen outside of Python. And an example is the Bevy inspector. It's a thing that allows you to just include it in your program, and you can then look at the particular properties of all the objects in your scene without paying for it. You do it by including the plugin, and then registering the systems inside your own application. Right, so what are systems? Systems are procedures that are executed on a schedule, but they are not just procedures. Systems let you choose what kind of types, what kind of components you are interested in, and they just get magically called at the point in time that you are interested in, the phases here. So if you have a system with position rotation and position velocity, you can decide where they get called. And maybe you can insert your system in between systems that someone else wrote. And this system, it can modify the same data. Hey, you can modify the same data of other systems. You can intercept the data that third-party systems are like trying to use. You can't do that in object-oriented. If one function calls another function, you can't just go in between. And here you can. This is related to visibility. In an object-oriented paradigm, whenever you call a method, you have two sources of, maybe three, but let's ignore the third one. Two sources of data. One is the fields on the class that you're called inside, and the other is, actually I missed this, the other is the data directly given to your method. Meanwhile, in an ECS, you get access to the entire world, the entire application state, if you only ask for it. If you're thinking, this is global state, you're right. This is global state. You can do whatever. You can insert any system to modify any data. That's the problem, because someone else can write a plugin and try to insert data that you were not expecting to be there, or modify the data that you carefully laid out and you don't know what's happening. Or this happened to me actually, that there was a system that I was trying to make it run, but the system wasn't really clarified of what I should do with my data for it to be able to pick it up. It's not like I can call a function. I have to prepare my data and hope that something picks it up. It's kind of annoying. There are no good tools, at least in Bevy, or at least I couldn't find them, good tools that would help me trace the data, because you're no longer tracing program runs. You're not longer debugging step by step. You're trying to trace the data and how it flows. So, good. You have global data in an ECS. It's great for iteration. It's great when you have many objects and you have something to iterate over. But it's bad because of this global data thing. It's bad when you have nesting, because you throw away the ability, the advantage of having objects neatly laid out, and you try to jump into other objects. So you have to do a lot more cache fetches. And it's kind of useless for single items, because like, what's the point of all this optimization if you're just going to process one object at a time? But speed is not everything, because there exists an ECS implementation in Python. And what is Python? Come on, what is Python? Python is slow. So there must be some other advantage to using an ECS. But let's take a closer look at why games are particularly using ECS. Well, they do a lot of physics simulation when you have lots of objects that you have to iterate over. And they have the batching, because you have to wait, collect your rendering operations, and then load them all on the GPU, reacting to the input. But why might it not be so great for games? Maybe because of networking needs. When you have like a networking, two applications are speaking to one another, and you generally want the replies to come as fast as possible, so you're going to process one message at a time, kind of lame. I also don't know much about sound, so I just included it here. And what else is like games? What else responds to user input and throws things on the screen? Come on, examples, ideas? There you go. A desktop compositor is just doing that. It's responding to input. Maybe it's doing some network in the background. And like, I'm okay. I don't have 10,000 blades of grass. I maybe have 50 windows, but maybe it's still okay. On the other hand, Wayland Compositor is like a heavily networked application, and it has like those bounces 1, 2, 3, 4 like replies where you have to establish some kind of resource, and you have to do like multiple bounces, and you have to do them like really fast. So you can't really wait and batch things. So also not a very good feed speed-wise. But that didn't stop me from making one. Don't bother compiling it. I said I didn't have the time to prepare for the presentations, but you can look at it for educational purposes. We're at a university, right? So I'm allowed to do that. Why I did it? It was because I was annoyed at Smithy. Smithy is a compositor framework written in Rust, but is also inspired by libwayland, which was written in the traditional object-oriented language of C. Before someone screams, you can write object-oriented code in C. And in object-oriented applications, you can have a lot of callbacks, and callbacks have very little visibility. Those hearts represent one callback coming with a single object of this kind, and another callback comes with a different object, and they don't really have this visibility. Remember the slide with local visibility of things? They don't have a lot of visibility into the entire state of the application. So if I've been working on input methods. Input methods, long story short, input methods talks to apps, an app talks to an input method, and they need to know, the input method needs to know which application is current, the application needs to know whether there is an input method. So they have to have references. An app has a reference to input method, and input method has a reference to app. But it's not so simple, because if the reference was just static, it would go outdated very soon. So you have to do the shenanigans, be able to open the visibility so the application can trace through the internals of the compositor to find which input method is currently active. It's kind of a mess, and you have to set it all up before you know how you're actually going to use this. You have to think about what you are going to use in the future while you're designing the interface. And meanwhile, in an ECS, all I have to do is create a system and create an event source. The event source is just an event source. It doesn't even care if I consume the events. So it's kind of a lot more decoupled. Yeah, that might be a bit difficult to understand, but I said focus. I feel okay with this. Not really. This is a kind of an example of a different problem that I had with ECS, or applying ECS to this problem. This monster is a kind of a callback that happens for every object in Wayland. And long story short, there is the data parameter, which captures everything relevant that you want to pass to this callback. But you're only allowed to set it at the beginning of the program. So it kind of forces you to give it the entire state of the application. And it's a static mood reference. Those who use Rust will kind of feel that is bad. I'm not going to deliberate on it, but it presents a problem because in Bevy, I never get to see the entire state. So I couldn't even use it. I had to hack it up. And why does Bevy do that? As you can remember, in an ECS, you have different rows that have different components in them. And this opens up the possibility of running things in parallel. So if you have a system A, B, it's only concerned with components A and B, it can run in parallel with the system D that is only concerned with this D components, and they can run at the same time. They are not going to collide because they actually need different separate data. That is really cool because you can do many things in parallel that are computationally intensive. And this is the magical parallelism of ECS. So I would like you to try ECS in your next application. Maybe it works, maybe it doesn't. But if it does, tell me. And yeah, questions, or maybe I should do a demo? I feel that I missed something, so maybe I'm going to do a short introduction. You remember the Foxes demo? In Bevy, you have this, every application is kind of made of three main pieces. The first piece is kind of where the magic happens. It's the startup function. You have your new application, you add the rendering plugins, without which kind of nothing in Bevy is going to run. And then you add, this is the real magic. You register your systems. No matter what it is, you just register it in the right phase. This is the startup phase, this is the update phase, and then you have the actual stuff that is going to run. In this case, the update system runs at every frame, so you're going to have an update of Fox rings. I'll get to that. But first, let's take a look at the setup, because it illustrates how to spawn things. You spawn your entities. There's the ring spawning, and this is the actual foxes that are getting spawned. So basically, let's take a look at this. You spawn a fox ring, which has a transform, which is the position, which has the visibility. It has some kind of a direction. and there is a ring. What is the ring? A ring is a component. So basically, the spawn of 4 components. And this is how you declare a component. Rotation direction is just a derived component. It just makes your component. There's another component that's called the ring. So they're like really fields, but they might be complicated, like substructures. So yeah, we have the components and we are spawning them within an entity. Looks good. So what do we do with them later? We have a system which is update fox rings. And as you can see, it takes a query. It's like a database where the query contains 3 different components, and then you do some processing on those components. So if you want to get started with Bevy, you have those 3 things. You have the application setup where you register your systems, you write your systems, including the setup system, and you define your components. And that's pretty much it. Right, so back to the presentation. If you want to tell me whether this works for you, that's me. I'm open to questions. Or maybe I have a question. Did it go too fast? Shaking heads. Okay. Is anyone going to try? I see some heads bobbing. Good, good.
I'm wondering if you have one system that does movement and another that does collision. Both would impact the position of the things. How do you prevent them from kind of running like messing with each other?
So that's actually what's happening a lot. You don't prevent them from messing with each other. You make sure that they are sequenced correctly. Where do I have that slide? Yes, that was actually the same thing. In this diagram, you have phases, and you make sure that the positions, the systems are running in the right order. In Bevy, it's defined that pretty much every phase, there are exceptions, pretty much every phase is being run once per frame. Doesn't have to be so, but you have to make sure that the ordering is right. With the Fox's system, it's actually kind of simpler because I don't think that there are any colliding systems. But you have this adding systems of updates, keyboard animation control, updates rings, and oh yeah, there is a sequencing. The rings are being added after the keyboard animation control. Thank you for pointing that out. So sequencing is very important. And the thing is, the systems are taking things as you requested them, so you have to be careful which components you take because you might create like some collisions that you didn't intend to.
There are no more questions.
I will pretend that it's because the presentation was so good. It's actually all animated separately. Oh, question.
I will come back.
It's not really a question, but you asked about how you can track the data changing. You can use the Bevy component hook, and it can track when the component is changed.
Oh yeah, there was like on change kind of something.
Yeah.
That's,
and you
that's a
can
good
print it out
point.
there.
It still doesn't solve the problem that some systems don't really have a very defined expectations of what components they expect on your object on your entities. But yeah, it's a good suggestion.
I mean, if you did it, then like a bunch of duplicates would probably show up, because the way it detects something changing is when it accesses the component mutably.
Oh, so because the Bevy scheduler like kind of knows what it's going to call, it's able to say that there was a change.
Mm.
Well, okay, you can still catch me after the presentation, I guess. I don't feel there is a lot of questions coming anymore. Thank you.